our goal in 10-1 is graphing square root functions, even though there are only 2 homework problems, homework page 548, 5 through 20 over the weekend. Even though those are only 2 homework problems, that's our main goal. And the steps to this main goal are make a table of values. Good, we practiced that yesterday, like what, 3 or 4 times, right? What was the goal when we were making those tables? Did we just plug in whatever numbers we wanted off the top of our heads, not even thinking about it? How did we make those tables yesterday? Oh, come on, you guys are doing great at tables. We can't have both yours. No, take one out. Take both out just because you have both in. Okay. How did we make those tables yesterday? We figured out what to plug in for x. We figured out what to plug in for x. And how did we plug in for x yesterday? They all had radicals. We checked, and we only wanted what coming out? The even nice numbers, right? So we wanted to have like a 9 that we could square root to be a, wait, what's the square root of 9? 3. Or we wanted like a 16 because we wanted a 4 to come out, right? Or we wanted a 5 to come out, so maybe we were shooting for a 25. Good, got a couple of you there. Or we wanted a 4 so that 2 would come out. Anyway, we were looking for the nice numbers in tables, right? So when you guys were trying to remember yesterday what a good table was for square root of x, just plain old-fashioned square root of x, what were the x's that you chose? What did you put down? You're supposed to remember. 0, that's a good one because square root of 0 is? 0. What else did you put? Because square root of 1 is? 1. Then what?
4.
Ooh, nice. Because that square root it is?
2.
And then?
9.
Good. And then?
16.
Okay. Do you see why I'm going to cross that one out, though? It's too big, because where am I going to take all these points today? The graph. Not in everything, remember, homework just has 2 graphs, but in some of them. I'm going to take these up to the graph. So I want you guys to go ahead and graph the point 0, 0, graph the point 1, 1, graph the point 4, 2, graph the point 9, 3, and let's see what these radical guys look like. Graph the coordinates 0, 0, 1, 1, 4, 2, 9, 3. Let's see what this graph looks like. You see why we stopped at 16.4? Am I going to be able to fit 16 on this graph? So are we going to have to be strategic when we're doing the homework problems about what numbers we plug into our table? Because I don't want to do decimals. Ew, gross. It's so much easier to do like the nice, hey, 1, 2, 3, got them. And then I want you guys to, now careful. Can or is there a square root of -1? Or -4? Or -9? No, why not? What do your calculators tell you anytime you square root of -1? Right? They shut up. They don't say error, something like that, right? Which means, even though I'm allowed to connect this way, am I allowed to connect that way? I'm allowed to come this way. Am I allowed to go back to the negatives? No. Square root functions are really, 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 really weird because they're not like parabolas in that they don't have a full swoop, they don't have a full U, they don't keep going to the right and to the left, they only go one direction. Ooh. Remember that with the band. Anyway, they only go one direction. That's it. Radicals. They have to have like a strict starting point because for this whole range of other numbers, they don't work. It's illegal, completely impossible. They're only allowed to go one direction. However, does anybody see how this kind of looks like a parabola, or at least half of one? You see how it looks like a parabola, or at least half of one? Don't do this. Pencils down, pencils down. I don't want you to mess up your graphs, but I do want you to see something. I don't want you to mess up your graphs, but I do want you to see something. This is the graph of y equals square root of x. The guy right up here. Can I show you the graph of y equals x squared right on top of this one? Because 0 squared, we got the wrong marker. 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. This this is the x squared function. Now the x squared function keeps going. He goes on both sides. But I only want to look at that one side. Do you guys see a relationship between the x squared and the square root? 0, 0, 1, 1, 2, 4, 3, 9. 0, 0, 1, 1, 4, 2, 9, 3. What's the relationship between these two? That is the same thing as that, but switch. And that's the very reason that anytime we see a squared, we're allowed to put in a square root and they undo each other. They are what we call inverse functions. And inverse functions, well, let me give you a hint. Inverse operations are the ones that undo each other. Inverse functions are ones that undo each other. The inverse operation of addition is subtraction. That's why we subtract things to the other side. The inverse operation of multiplication is division. That's why we divide stuff to the other side. And now we have this new, the inverse operation of squared is square root. But anyway, don't worry. We don't have to graph square roots with squares. That's much more of an Algebra 2 pre-calc thing. For us, we just have to focus on the radical guys. Now, hold on. Make a table. Check. Use the table to graph. Check. What's step 3? It's in the notes, not in the worksheet. It's okay. Do you see it? Step 3. Describe the who or what?
Range.
Yeah, range. But first up, do you guys have a domain space and a range space for this graph?
Yeah.
Okay. So, and wait a minute. Don't you kind of have over to the side something next to domain and something next to range? Check it. Ready? Let's go ahead and dual page. All my guys are getting tissues. That's awesome. So let's go. Let's go. I don't think you really need it. Go ahead.
I did.
Well, you should have been laughing at Danny as you were blowing your nose.
I wasn't.
Go ahead. Let's go. Go to your seat and you can hold it back in. Danny, you stick on your seat. Okay. So, let's start with domain, then we'll go to range. Let's start with domain, then we'll go to range. Okay, if you guys look at the rest of this packet, are all of them as easy as square root of x? No, it's a little bit messier, right? Look at 1 and 2 and 3 and 4 and 5 and 6. Okay, look at the directions of 1 and 2 and 3. What are the directions of 1, 2, and 3 say? Good. Describe the domain. Describe the domain. What was the domain of every parabola? And almost everyone got it right on their test. What's the domain? You guys did test corrections on your parabolas recently. What was the domain of every parabola? All real numbers. Can I put, Everson Andrew, can I put all real numbers for this?
Oh.
You're just reading my face. I'm curious as to why the answer is what you think it is. All real numbers, yes. Quadratics were like that. But wait, domain. Some of you were saying no, like with conviction, which I'm kind of excited about because I'm kind of hopeful you know why it's no. Domain is not all real numbers because remember how domain tells me about the x's? And range tells me about the y's. If I were you, I'd put this on your worksheet. A quick reminder. Domain tells me about the x's, and range tells me about the y's. If I were you, I would put a little reminder of domain being how left to how right. The x's are the guys on the x-axis that go left and right, side to side, right?
Yeah. Yes.
So if x's go this way, then question. What kinds of x's are allowed, or maybe I should say, what kinds of x's are not allowed? How left does this go? Yeah, go to your x's. Go along your x-axis. It goes to x equals 0, and it can't go before because we're not allowed to have negatives under our square root. So if we're not allowed to have negatives under our square root, well, we can't have the negatives, so we can't say all real numbers. Instead, what is the domain of this guy? X is greater than or equal to 0. I'm allowed to have 0. I'm allowed to have positives. I'm not allowed to have negatives. And you guys told me that in words. You just weren't ready to answer the question when I asked it. Because you probably weren't ready with the word domain. So write down whatever notes you need with domain. Domain, the x's, how left, how right. I am not allowed to have negatives. So x has to stay greater than or equal to 0 for this guy. For this guy. But can you come over here to this guy? I'm trying to prepare you for other stuff showing up underneath the square root. Look at 1, 2, 3, 4, 5, 6. Other stuff comes under the square root. So here's what we always are going to do. Set the radicand. Radical is this guy, right? If I was to label stuff. Radical is the sign. It's a radical sign. We can also talk about the function being a radical function or a square root function. But the radicand is who's underneath. Oops, I can't even spell it. It's going to spell it like randicand. I don't know what that is. Radicand. So here's what you're going to do. To find your domain. To find your domain, you are going to try to figure out x, and then you're going to try to figure out x x range. No, x interval. Let's do x is allowed. And to find the x's that are allowed, we're going to take whatever is underneath the square root called the radicand. We're going to set it greater than or equal to 0, and we're going to solve for x. Now, in number 1, that wasn't a big deal because, guys, who was under, well, it wasn't even number 1. Sorry, wasn't it like letter A? You guys don't even have a number on it. Who was underneath the square root to begin class today? X. So when I say set the radicand, who's underneath the square root greater than or equal to 0, we were already done. X was already alone. We took our radicand, who was x, put him greater than or equal to 0, and we were done. But is that going to be, we'll come back to range in a second, is that going to be so easy in all the problems? Do you guys see numbers 1 and 2 and 3? Number 1, who is underneath? I want you to box it. Who is underneath the radical? Who's the radicand? Literally, box it. Even my pre-calc kids still have issues with this today. So, come on, follow my system to help you. 3x is underneath. Who's underneath in number 2? Negative x. Oh, you have it on your worksheet. You don't need to see up here. Look at number 1. Who's underneath? 3x. Box him. Number 2. Who's underneath? Negative x. Box him. Number 3. Who's underneath? Oh, the whole thing. The whole thing, Everest. X minus 8. The whole thing. X minus 8. Box it. What do we call all of those boxes? What's their snazzy term? Radicand. Okay? So those are all the radicands. What am I supposed to do with each of those? One by one to find my domain. Solve for x only after, what are we supposed to do with the radicand? Set it. Set it greater than or equal to 0. It's as easy as that. And for those of you that are in your books looking at homework, isn't numbers 5 through 14 all talking about domain? Just like numbers 1 through 3? Wait a minute, I'm not done. I'm supposed to get x by itself. I'm supposed to solve for x. So guys, how do I get x by itself? Yeah, inverse operation, division. Get rid of that multiplication. X is going to be greater than or equal to 0. Guess what? You're done. That's not bad, as long as you follow the system and the formula. So my question is, how would you apply the system or the formula to number 2? You have your radicand already. What do you do with it? Oh, come on, follow the words. Just read me the words. You have the radicand. What's the radicand in number 2? Negative x. What do you do with the radicand? Okay. Read it. Set the
radicand greater than or equal to 0.
Okay, I can follow those directions. The question is, can you? Take the radicand, set it greater than or equal to 0. Guys, go ahead and set the radicand greater than or equal to 0 in number 3. Careful, greater than or equal to. Careful, greater than or equal to. Allowed to be 0. Good try. Remember those inequality properties. We haven't finished number 2 yet. I'm just curious if you can follow the directions. So guys, on number 3, you tell me. I'm telling you set the radicand greater than or equal to 0. So what did you do? What'd you write? Keep going. Okay, not bad, right? Now here's my question. Do you know how to get x alone? Plus 8. That one's easy. Plus 8, plus 8. Haha. That's a rundown. X is greater than or equal to 8. Okay, fine. Whatever. But did if you know number 2, Trey already got it right, but he called me over just to double check that he had done it right, because number 2 is a little tricky. You have to remember something about inequalities. How do you want to get epsilon? Do you want to divide, or do you want to add? Most of your brains will think divide. But if you think divide, you could get in some serious trouble if you don't remember that whenever you multiply or divide a negative number with an inequality, you have to switch or flip the sign. Do you remember that? X is going to be less than or equal to 0 divided by anything is 0. Now, if you're like, oh, dang, I forgot that problem. Can I show you how you could have also used addition to get the right answer? I know your brain is going to think division. I get it. It's -1 times you divide. But check it. What would have happened if I had added instead? Totally legal. What's -x plus x? See it? What's the sign? Stays the same. What's 0 plus x? The reason why we have to flip the sign is because we need the division to give us the same answer addition would. I know your brain's not going to think addition. But because of this negative sign, guys, truly the x needs to end on the short end of the stick. He needs to end on the less than or equal to side. Which, okay, most of you aren't, I'm going to put this in parentheses, like big old yellow parentheses. Most of you aren't going to think of that, and that's okay. But what I need you to remember is whenever you multiply or divide by a negative, one more time, what are you going to do to the sign? Flip it. Okay? Hey, wait a minute. So does that mean we're done? With numbers 1, 2, and 3? Which is 5 through what part of homework? Andrew, you have it. 5 through 14. 5 through 14 is just domain. But then there's some other parts of homework. Guys, what haven't we filled in yet? We've talked about domain, but what haven't we talked about? Range. Okay, look at 4 and 5 and 6, yeah? Look at 4 and 5 and 6. So 4, 5, and 6 say, all right, range. So you ready? Let's come back to range. Back up at the top, I have a couple things for us to fill in. Now, range says, range says we're supposed to graph. So, guess what part of the question is when you get to these two? Not just graph, not just think how high, how low, but answer the range question. So if you guys want to, actually, you know what would be a really good idea for you getting ready for homework? If you're going to use this for homework, can you guys underneath the graph right now just write the word range? For homework, can you just underneath the graph? You're going to have to get the graph first, but then once you get the graph, you're going to be able to answer the range question. Now, range, hold on. We just wrote this down a second ago, right? Isn't range the y's? If domain was answering how left does it go on the x-axis, how right is it allowed to go on the x-axis, or which x's are allowed and which are not. Range is going to answer how low or how high. I'm going to say or, maybe you should write that on your paper, because either it's going to go up forever or it's going to go down forever. So to some extent, I'm not asking the forever question, I'm asking the limiting question or the boundary question, or what's the lowest it goes, because it goes forever high, or what's the highest it goes if it goes forever low. So I'm looking for the lowest or the highest. Looking for the lowest or the highest. Let's go back to that original graph, the one that we filled in the domain to. Let's fill in the range. Okay. We're not looking at the x's anymore. That was domain, and we said to 0, and that's it. So anything greater than or equal to 0. The range asks a very different question. It says how low, how high. I'm not looking at the x's, the horizontal anymore. I'm looking at the y's. So how low on the y-axis is this allowed to go? 0. See it? I'm not allowed. It's not allowed to go any more or any further. So therefore, okay, the answer is actually going to be the same in this one. The answer is going to be the same in this one. It's x greater than or equal to 0 or y greater than or equal to 0, but be careful. How left does it go? X equals 0 was the lowest it goes on the x-axis, but y equals 0 was the lowest it goes on the y-axis. They're asking two very different questions. How left, how low. Now, Seems a little confusing until we do some examples. So, we're going to do some examples, and as we do, let me give you guys a couple hints, okay? If it's one of these swoops, it's going to go forever high. If it's going to go forever high, that means the y's are going to be greater than or equal to the lowest. Now, we have to figure out the lowest. If it's a how low question, that means it's one of these guys that's swooping up. He's going forever high, and if he's going forever up, then I'm going to answer y is greater than or equal to the lowest y value, whatever that, I'm going to put a question mark, whatever that lowest y value is. However, if the swoop is the other direction, if it's gotten flipped somehow, I'm not answering y is going to be above the lowest. I'm answering y is going to be below the highest. This is how I answer range. And the problem is you got to have the graph. Even the older kids, if they're not showing work, if they're not actually graphing, they're supposed to be, they need to be thinking of the graph. So here we go. I'm going to zoom in on, well, you guys can read them on your paper, right? You don't need to see mine. Number 4. Can we look at number 4? Number 4, if we were to graph this, can you guys help me out? We want nice tables to make nice graphs. If we don't have nice tables, everything gets messy and decimals and blah. So question, can you guys really quickly, can you box for me the radicand on number 4? Who's the radicand on number 4? Good. Okay, x is the only thing under the radical. So the nice thing is, you ready? In our table, we can fill in that 0, 1, 4, 9, 16, and 16 is probably too big. I can fill in those nice numbers from the very first graph because only x is underneath. If only x is underneath, sweet, let's use that 0, 1, 4, 9. Now be careful though. Can I plug in 0, 1, 2, 3, just like I did at the top? No. The answer why is because don't I have to plug in square root of 0 to 4 plus, right? Or square root of 1 to 4 plus, or square root of 4 to 4 plus, or square root of 9 to 4, right? It's not going to be the exact same y's, but I am going to use the 0, 1, 4, 9 because those were the nice easy ones. Right. Okay, so what's 4 plus square root 0? 4. You guys have these memorized yet? Square root of 0 is 0. What's square root of 1? 1 plus 4 is 5. Yeah. You see it? Yeah. So what's the next one going to be? 8. No. Careful. 6. Yeah. You see it? Square root of 4 first, just like yesterday in the worksheet. Square root first. Square root of 4 is 2. 2 plus 4 is? Got it. And then what's the next one going to be? 7. Oh, well that's not bad. So 4, 5, 6, 7. Can I zoom in on the graph so we can see what's going on? You guys, start graphing those points. Those are ordered pairs, right? X's and Y's. Make sure you remember that X's are how far over you go and the Y's are how far up you go. Yeah? One is going to be at 5. 2 is going to be at 6. 3 is going to be at 6. Oh, no, wait a minute. No. 0 is at 4. 1 is at 5. Then I have to go all the way over to 4, 6. Then I have to go all the way over to 9, 5. Okay, now hold on. It's really important. Do you know how to connect? Do you know how to connect? Yes. I'm going to swoop it, but why am I only swooping it one direction? I can't swoop it the other direction. Those are going to be negative. That's illegal. Right? Now, if we wanted to be super snazzy, we would talk about domain also, but they're not even asking us about domain. So guys, what did you do on the back of the paper that we should probably do underneath this graph? What else are they asking? Good. Range. So hold on. Is this one of those we're looking for the lowest or we're looking for the highest? Can you look at your little guide? Yeah. Did you write it down? Double check real quick. Did you write it down? If it's one where it's swooping up, we're looking for y greater than or equal to the lowest. If it's swooping down, we're looking for y less than or equal to the highest. But you guys see how it looks like this one, right? It's swooping up. So therefore, I'm doing y greater than or equal to, how low does it go? low does it go? Check your graph. How low on the y-axis does it go? 4. Got it. Y greater than or equal to 4. Can you guys try to make a table and a graph for number 2? And the good news is, let me point it out real fast, and I'll walk around and answer questions if someone got lost. The radicand, careful, look at the radical. It stops over the x. It stops over the x, which means I can use my really cool, 16 is too big, we'll just forget 16. But 0, 1, 4, 9. We can use 0, 1, 4, 9 because, guys, there is no shift on the inside. Remembering yesterday, the shifting, where we have to change our table, is only if there's a minus or a plus under the radical. And number 5, there's none. It happens outside the radical. Ready, set, make me a table, make me a graph, and try to find your range. Let's say you have a job where you make a commission. Do you know what a commission is? When you make a commission. When you go in, could you be worried about how much you're going to sell, so how much money? So what a lot of people are going to ask when they go into the job is what's the lowest that they pay? Meaning, if I sell nothing, am I still going to make some? Well, it depends. It depends on the job. Usually they pay per hour when you make extra commission. So the question in my mind for paying my bills is like, what if it's a bad month or stuff and you can look at the lowest times in a week? How much money could you make? How much could you sell? There's no limit, however much you can, right? So even though I can make all this, I care about it, right? Because that's important for me. So the range is kind of saying, okay, if you go on forever, why could you anything higher than this to be the lowest equals like have a gauge or have a reference? Does that make sense? Yeah, so it's just because it's not. Good question. Yeah. Hey, have you guys plugged in? I'm just going to see if you plugged in right. I'm not going to answer the range question quite yet. If you guys get this one, you can be pondering the last one, because the last one's even trickier, because you can't just use 0, 1, 4, 9. You shouldn't use 0, 1, 4, 9. How's that focus point? So when we plug in, we get square root of 0 minus 1, square root of 1 minus 1, square root of 4 minus 1, square root of 9 minus 1. Check your table. Is that what you did? Is that what you graphed? Is that? Yeah, no, sorry, Kim. Look, you haven't even caught up with us. There are a few people in this class that by listening to music in one ear actually get more done. But those of you that are getting less done, I'm sorry, I can't let you do it. Good job keeping up. Okay, when we plugged in. It's a little funny. Well, it's just because we want that swoop. You kind of see what I mean? Either this way or that way. I'm going to start, wait. What was in the table? Square root of 0 minus 1. Mental mathers, you get 0 minus 1? Negative 1? Okay. Now mental mathers, what did you get on this one? Got it? This one? Got it? This one? Okay. So we have our, careful, you got to do the square root first. And then subtract. That's what we were seeing yesterday in that chapter 10 intro worksheet that was due today. I'm waiting to grade it until we grade 10-1. I'll grade the intro and 10-1 A and B. So those of you that had it ready, I saw you guys out with it on your desk. It was perfect. It was awesome. Thanks for doing that. So when we graph 0, negative 1, oh, that's weird. It goes down below the axis. 1, 0, okay. 4, 1, okay. 9, 2, okay. Let's see if I get it. Yeah. Cool. Do you see the swoop? If the swoop's not there, we're in trouble. Danny, is it good? Cool. Now here's the question. Are we looking for y greater than or equal to the lowest, or are we looking for y less than or equal to the highest? Which one is this graph? Lowest, yeah. Y greater than or equal to. Because remember, the range is saying, hey, how many y's? And I'm like, well, I can go forever, so I'm not going to talk about that. I'm just going to put a greater than or equal to, saying y is allowed to go above. Above what, though? What's the lowest it can go in this one? Rock. But why was I trying to get some of you guys, if you're understanding this perfectly, to go ahead and start thinking about this one early? Has anyone gotten there and thought about it yet? Danny? Yeah, what made it weird?
Oh, there's you have to add them together.
Yeah, you have to add the x's together before you square root, which is dangerous because I like plugging in 0, 1, 4, 9. Those are nice numbers. But now all of a sudden I have to add 5 and then square root? Do you guys remember what we're supposed to think of when we see an inside shift about which way it shifted? Yeah, is it shifting forward 5 or backwards 5? If it's adding 5, is it shifting adding 5 or subtracting 5? Wait, are you adding 5 or subtracting 5? You're subtracting because it's opposite. Whoa, where was everyone else? Are you even awake? Come on, I know it's a Friday, but look. Whatever's here, think opposite. So what do you see? Adding 5. What are you supposed to think? Opposite. So think. What's opposite adding? Subtracting. Okay, so instead of saying 0 plus 5, 1 plus 5, 4 plus 5, remember yesterday's worksheet? Go the other way. So check it. Why am I going to start my table at -5? Plug it in, plug it in. What happens when you do -5 plus 5?
0.
I get my 0, and -0 is just 0. Oh, okay. I get my nice 0 square root. So how am I going to get my nice 1 square root? Go back 5 from this guy. And what's going back 5 from 1? Go back 5 from that guy. What's 4 minus 5? Go back 5 from that guy. And then, I mean, we could do another one. 16 minus 5 would be 11. It would almost fit on my graph, but okay. Now some of you are like, wait a minute. She gave us a bad graph. And you're entirely right. I did give you a bad graph. I didn't shift it left 5. That's my bad, huh? So we're going to have to go -1, -2, -3, -4, -5. We're going to have to make our graph a little bit bigger. But when we plug in, guys, these new numbers of -5, -4, adding 5 to each of them, -1. Now, you could have just been guessing all day long and keep on plugging in stuff and being like, oh, man, this is awful. Nothing is going to be a nice square root. But if you use these tricks I'm trying to show you that actually work for not just quadratics, but also square root and any other function of shifting, I can kind of help myself get a faster, better, nicer graph. Because what is the square root of 1? Yeah, times a negative. Okay, -1. Whatever. What is the square root of 4? Oh, I know that one. It's 2. Awesome. It's a nice number. And what is the square root of 9? 3. But why are there negatives in front of all of these? So what was in front of the square root at the beginning? So, guys, what happens when I graph this guy? Now, careful. Did you extend your x-axis a little bit? We got to get -4 and -5. Right now, we just have -3. I'm sorry, my bad. I should have shifted this graph to the left, and I didn't. But what's going to happen when I graph? -5 is at 0. Do you guys get it? -4 is at -1. -1 is at -2. Oh, wait. Whoa. What's going on, guys? It's going down. So, Andrew, hold on. Everest, hold on. Everything's just changed a little bit. This guy's not going up. This guy's going down. So if this guy's going down, if I need to do my range, am I going to say y is higher than a low point or lower than a high point? Yep. Y is less than or equal to. Okay, what's the highest this can go? Look at the y's. Good. 0. What was today's goal? To play with tables some more, to get us ready for the graphs that are coming, and to talk about two things with these guys called square root, or if you guys want to be super snazzy, radical functions. Domain and range. Domain. Can you help me out at the very top of the page? Domain. What are we supposed to do? Look next to it. Set the radicand, the guy under the square root. What? Well, hold on. Set him. What is he? Not lower. Greater than. Did you guys get that in your notes? Hold on. It's going to be super bad if you don't get that one. Remember, domain. We got to set the radicand. Did you fill it in? You had to write this in. I wanted you to make sure you caught it. Set the radicand greater than or equal to 0, right? And then, Danny, yeah, you were right. Solve for x. Good. Andrew.
We always put it.
Yes, for domain, because domain says who's under the square root must stay positive. Well, 0. Yeah, that's based on like the property of square roots and what we saw in our calculators when it said error for any negative number. Now, hold on, Andrew. When we solve for domain, isn't it possible that this somewhere in here has to flip because of what's underneath? Yeah. So then when we solve for x, it might move around a little bit, but we always start the same way. Always start radicand greater than or equal to 0, radicand greater than or equal to 0, radicand greater than or equal to 0, then solve. Is that good? But range, what's different? Can we just look at the equation? We need to look at the graph. When we look at the graph, we say, okay, are you one of those that's going forever high, so we say y is greater than or equal to the lowest? Or are you one of those that's going forever low, so we say y is less than or equal to the highest? But you can't know the graph until you make it. So I'm going to go ahead and open up. I have your guys' oh my goodness, 6 minutes left of class, guys. This is exactly what we want to be doing every day, right? Finishing our notes and getting into our homework. Some of you guys were working on the worksheet to finish it up last night. So I did want to peek at that worksheet for just a second or two because we've had it yet. But in some ways, it didn't have a lot to do with today. In that you guys were just practicing on how to, well, where did it have something to do with today? Yesterday in that worksheet, weren't you guys doing things like solving expressions with radicals? What do you see that you're going to have to be doing in homework that makes you solve expressions with radicals and know that you're supposed to go evaluate the radical first? Every time you fill in the table. Every time you fill in the table, you're going to have to be thinking through what the worksheet was having you practice last night. Go to the radical first. Answer him. If he's nice, awesome. Let's go. If he's not, is there a better one I can choose? You guys can see right here, numbers, everything from homework, can't you? There's 5 through, oops, let me get rid of that. You can make it full screen. The question is, where are you guys going to do your homework? Are you going to do your homework in a homework spiral? You can get it out and start working. But if you're like, wait a minute, don't I have something on my paper? Didn't I already tell you there are only the last 2 problems in homework that need this? Worst comes to worst, and if you're like, I don't want to like set up my whole homework page right now, can't you do numbers 19 and 20 on the paper right now? And have the hardest part of homework, which is the end done first? Good team. If you want to use your worksheet for numbers 19 and 20, you could start right there and look at the directions. Graph the function. How? Make a table. After you graph, talk about the range. How? Fill it in just like we did in class. If you want, you can do your homework backwards. See if you can finish numbers 19 and 20 before you do.
Yeah. Just being able to use it.
Hey, you can get dumped under 19 and 20 right now. I think the rest of the homework might be a little bit easier. Have your worksheet closed when you do homework tonight. Oh, not 19 and 20. We have 5 minutes. You're not following the directions. I said work on 19 and 20 or start doing that. I wouldn't say pass that. Yeah.